Okay, this is the final video, hopefully, for Unit 7, talking about law of cosines. So just to recap, in the last video, we talked about, we have transitioned to looking at not just working with right triangles, but looking at triangles that weren't right necessarily and solving them, which means finding all the side lengths and finding all the angle measures. And we said that for law of sines, we could use law of sines when we were given two angles and a side, or two sides and a non-included angle. Well, law of cosines, which I'll write for you in a minute, we can use when we have all three sides or side angle side, meaning we have two sides and the angle included between them. Now, so in terms of thinking about what the law of cosines is, let me just write a generic triangle here. So A, B, C, and then A, B, and little c. Okay, so let's just say we needed to find side length A. The law of cosines rather, is A squared equals B squared plus C squared minus 2bc cosine of A. Or we could say B squared equals A squared plus C squared minus 2ac cosine B, or I could say C squared equals A squared plus B squared minus 2ab cosine C. So just different versions of the law of cosines depending on what is missing. And this also would work for the, if you had a right triangle, because in a right triangle, cosine of A, cosine B, cosine C, all of those, cosine of 90 degrees is 0. So you would just left with our standard Pythagorean theorem, A squared equals B squared plus C squared. Okay, so again, if I'm presented with one of these two situations, I'm going to use the law of cosines. And when you have, unlike the only special case with law of sines where I could have two possible triangles that meet that condition was SSA, that's the only case with all 5 of these scenarios. So I shouldn't be getting two triangles with SSS or SAS. And in order to ensure that I am in fact getting the correct triangle, when you have SSS, I'm first going to use the law of cosines, and I'm going to find the largest angle first. And the reason that's the case is, with the law of cosines, if I end up with cosine of A, so say I'm using the law of cosines to find A, if I end up with cosine of A being a negative ratio, not a negative angle, then I know that A is going to be obtuse. Whereas if cosine of A is a positive ratio, then I know that angle A will be an acute angle. So in other words, by finding the largest angle first with SSS, I don't have to worry about missing an obtuse angle if there is one. If there is one, the largest angle will be it, and that will come out using the law of cosines. So again, when you have SSS, find the largest angle first. How do I know which angle is largest? It's always going to be opposite the longest length. In terms of when and once you find that, then I'm going to use law of sines to find the other missing pieces. If I have SAS, I'm going to first find the missing side length, and then I'm going to use the law of sines to find the smaller of the two remaining angles. And the reason I'm going to find the smaller is I know that if it's smaller, it can't be an obtuse angle, because of course you can't have two obtuse angles in a triangle. So I know the smaller one has to be acute, so I can ensure that I actually am finding the right angle there. Okay, so let's do an example, and we'll do one, maybe we'll do an application example. Let's see. Let's do some bearing problems. Okay, actually, before we do a bearing, maybe I'll do one of the solves. Let's do one. Okay, I've got A, B, C. I'm just, again, going to label it. 28.2, C is 46.7, and angle B is 73.5. Okay, so I indeed here have SAS, so I'm going to jump to law of cosines. So in doing so, I need to find this B length. So B squared equals A squared. Well, it looks like I'm doing C squared first. That's fine. 46.7 squared plus 28.2 squared minus 2 times 46.7 times 28.2 times cosine of 73.5. And then you find B squared and then take the square root and get 47.2 feet. Okay, so that is B. And now I have two angles left. Let's use the law of sines to find the smaller of the two. So the smaller is going to be angle A. So sine of A over 28.2 equals sine of 73.5 over 47.2. And you'll end up with A being about 34.9 degrees. And then to find C, it's just going to be 180 minus the two angles, 73.5 and 34.9. So C ends up being about 71.6 degrees. All right, let's do an application because I think it's important to think about and look at bearing problems. So let me see if I can find a good one to do here. Let's see. All right, let's do number 9. So let's go. All right. An airplane flies 180 miles from point X on a bearing of 125. So every time I do a bearing problem, it's because we're not just going to be working with right triangles, it's really important to label angles as you go to keep track of things. So I'm going on a bearing of 125 for 180 miles. So this is 180. And since it was 125, this angle here is 35 degrees. Okay, and then I'm going to turn and flies at a bearing of 230. So 230 for 100 miles, so a little bit shorter. And actually, let's change that a little bit so it's not so messy. And so 100 miles. And since this was 230, this angle here will be 40 degrees. And we know that the 35-degree angle, this also is 35 degrees because alternate interior angles are congruent. And so the question is, in this case, how far is the plane from point X? So we're finding this distance here. And so I've got this angle here as 75 degrees, and I've got two side lengths. So I have SAS, so I can use the law of cosines to then find X. So X squared is going to be 180 squared plus 100 squared minus 2 times 180 times 100 times cosine of 75 degrees. And when you solve and then take the square root, you should get 181.9 miles. Okay, so, and then I'm actually going to do one more video after this to talk about how to find, do a problem on the review sheet about actually finding a bearing. Because I think those are particularly interesting. Okay, so actually let's do 10 and then we'll be done with this video. So 10, find the area. So if the sides of a triangle are 850, 925, and 1300. So remember area, to find an area, I need two side lengths and an included angle. So let's find let's see which angle we should find. We should, it's always a good idea when you have SSS to find the biggest angle first. So that means we're gonna find, not that. Yeah, who cares how I label it. So let's find angle B. So I'm going to have, so remember, to find angle B, I can manipulate this formula. B squared equals A squared plus C squared minus 2AC cosine B. So if I solve for cosine B, that's going to be A squared plus C squared minus B squared over 2AC. So let's fill that in. We'll have, so let's see, 925 squared plus 850 squared minus 1300 squared over 2 times 925 times 850. And again, remember that's cosine of B. So this, when I then find what cosine B equals and do inverse cosine, I'll get B is 94.08 degrees, which actually is an obtuse angle. But now I have an included angle. So I have 94.08 degrees. So I can use the area formula to find the area of this triangle. So area is 1/2 925 850 times sine of 94.08. And this area ends up being about 392,129 miles squared.